Hey everybody! In this problem, we are going to be working at a kinematics problem that asks how far a ball thrown at an angle travels. This is a 2D kinematics problem. Let's go ahead and highlight key information. So a ball is thrown 30 meters per second at an angle of elevation of 40 degrees. That's the new part. How far away will it land? Typically, when you're doing launching projectiles with kinematics, it's always been when will it land, how high will it go. Since this is a two-dimensional kinematics problem, we can actually solve how far away from you it lands. Two parts. For part one, we have to determine when does it land. So this is old one-dimensional kinematics problem, except that we have to use the y component of our velocity. So not that 30 meters per second, we have to break that into a y component. And to do that, like all vectors, it's the magnitude of the vector multiplied by the sine of the angle. So our vertical component of our velocity is going to be 30 sine 40. The y component of our velocity is going to equal 19.3 meters per second. That means even though our ball was thrown at 30 meters per second, it's actually being thrown 19.3 meters per second up. Now that we know that 19.3, we can actually solve this like an old physics 11 kinematics problem because we know it's up velocity, we just want to know when it lands. So that's our d equals 1/2 at squared plus vit plus di. We know the acceleration due to gravity, that's negative 9.81. The vi, velocity initial, must be the vertical velocity. Do not accidentally go back up and fill in that 30. That 30 was at an angle, not vertical. We can clean this up a little bit, and we get that our distance is equal to negative 4.9 t squared plus 19.3 t, and no di, because in this question I was nice and the ball was thrown from ground level. If we want to know the time that the ball hits the ground, we have to fill in 0 for our distance. That's when it hits the ground, when the height is 0. And there's going to be two answers. And if you're doing two-dimensional kinematics, I trust that you have a whole bunch of ways to solve quadratics right now. You might do this graphically or chuck it into the quadratic equation. Since there's no c value on this one, I'm just going to do it out nicely by factoring because I can factor out that t. You use whatever method you want at this point in order to solve a quadratic. We factor a t out in front and we get negative 4.9 t plus 19.3. We know our first answer, that first t is going to equal 0. That makes sense. It was at ground in the beginning. In order to get the second one, we have to set that second factor equal to 0. 0 equals negative 4.9 t plus 19.3. I want to get that t all by itself, so I bring the 4.9 t to the other side by adding 4.9 t. And I want to finish this off. I will divide both sides by 4.9, and it'll equal t is 3.94 seconds. That's how long the ball was in the air. Because I now know how long the ball was in the air, it is time for part 2. And part 2 is how far. So we know when it lands, but we don't know how far away it went in those 3.94 seconds. Well, in order to figure out how far away it went, we used vertical velocity. Now we're going to have to use horizontal velocity, the Vx component, because that's going to tell us how far away it goes. Just like all other vectors, to get the x component, it's v cos theta, so the magnitude of the original vector times the cos of the angle. That's 30 cos 40. Our horizontal component of our velocity is 23 meters per second. That means the entire time that this ball is in the air, it is moving away from us at 23 meters per second. That has nothing to do with going up and down. It just means it's doing that the whole time. Because that's constant, we can actually use v equals d over t. Fill in 23 for our velocity, 3.94 for our time, multiply that out, and it tells us that the distance away that the ball went was 90.6 meters. So once you've done all the tricky work of finding out when the ball lands, horizontal velocity is constant for the whole trip. That means it just sailed away at 23 meters per second for the whole 3.94 seconds, which means it went 90.6 meters. I hope that this example was helpful for you. If you have any questions, please leave them in the comments below. Thanks for watching, and I'll be looking forward to seeing you next time.